In this video, we'll write the net ionic equation for CaOH2 plus CH3COOH. This is calcium hydroxide plus we have acetic acid. Acetic acid, sometimes it's written like this. You'll often see it written like this. They're actually the same thing. It's just organized differently. So either way, this H here, that's what makes this an acid. Here they have this H in front. So we'll use this form here in the video, but those are two ways you can write it. We need to balance the molecular equation. That's the first thing we do when we write net ionic equations. To do that, it looks like we could put a 2 here and a 2 in front of the water. That would balance the molecular equation. Once we have the molecular equation balanced, we need to write the states for each of these compounds here. Calcium hydroxide, that's a strong base. That means it's going to dissociate completely. It's a strong electrolyte. We'll put an AQ after it. This acetic acid, it's also called ethanoic acid, that's also aqueous. It'll dissolve in water, but there's a little bit of a difference here. While this will dissolve in water, it's not a strong electrolyte, so it's not going to dissociate. It'll just dissolve, it won't split apart in its ions. That's because this is a weak acid, so that's a good thing to remember. Over here we have calcium acetate, so calcium and acetate compounds, both of those are usually soluble. Put a little AQ. It will dissociate, dissolve into its ions, and then water is a liquid, and we'll just put an L there. For net ionic equations, we don't break up liquids. We have the states. Now we'll split the strong electrolytes into the ions. That'll give us the complete ionic equation. Calcium is in group 2 on the periodic table. It has a 2+ ionic charge. The hydroxide has a 1-. This is one that you should remember, OH-. We have 2 of those, so that balances that out. For the weak acid, acetic acid, we don't do anything. We're not going to split it into its charges. Then calcium acetate, we said that broke apart. Again, calcium is a 2+. And this acetate ion, we could look that up to see what the charge on that ion is on a common table of polyatomic ions here. And the acetate, that's negative, which isn't surprising because if we have 2 negatives, that balances the 2+. We said water, we don't do anything to. Okay. So we have these ions listed and we have the states. Let's split up the strong electrolytes. We have Ca2+, that's the calcium ion. I'll write aqueous at the end. Then we have OH-, that's the hydroxide ion. And this 2, subscript 2, means we have 2 of these. So we'll put a coefficient of 2 in front of that. Plus, we have the acetic acid here, which we said we're not going to break up, and we do have 2 of them, so we need to put that 2 there. These are the reactants. For the products, we have our calcium, Ca2+, and then we have that acetate ion, CH3COO-, and the 2 means we have 2 of those. Put a coefficient of 2, plus we have the 2 water molecules. So this is what we call the complete ionic equation. Everything's listed here. And the strong electrolytes, they're broken up into ions. Now we can cross out the spectator ions. These are ions that are the same in both the reactants and in the products. So we have Ca2+ here, Ca2+ here. We can just cross that out. It hasn't changed. Hydroxide, we don't have that on this side. And then we have the acetic acid here, and then we have the acetate ion. So these are very different. So all we can cross out, that's those calcium ions. Let's clean it up, write in the states to have the net ionic equation. So this is the net ionic equation for CaOH2 plus CH3COOH. One last thing, since we have 2 in front of each term, we can reduce that down to a lower number. We can reduce that to 1, and we don't write the 1. So this would end up being the net ionic equation for CaOH2 plus CH3COOH. This is Dr. B, and thanks for watching.